Welcome to the Project Management PrepCast, helping you prepare for the PMP exam. Here's your instructor, Cornelius Fichtner.
Welcome back. This is part 2 of our lesson on control schedule, and I'm your instructor, Cornelius Fichtner. In part 1, we covered the overview and the inputs for our process, and now we're moving on to the tools and techniques, the outputs, a review, and, of course, a sample exam question as well. There are 7 tools and techniques that we can use to apply to our inputs in order to manage and control changes to our schedule. They are performance reviews, project management software, resource optimization techniques, the scheduling tool, modeling techniques, leads and lags, as well as schedule compression. And by the way, the word control is of utmost importance here because we are not simply going to record the changes, but we want to control the changes and bring any deviations from the baseline back into alignment. That is the point of control schedule. Have you ever heard the saying, hindsight is 20/20? It's actually quite applicable here. Performance reviews measure, compare, and analyze schedule performance over time based on data like actual start and finish dates, the percentage of work complete, and the time, the length, the duration that's remaining for the work in progress. Projects can manage not only going forward, but in hindsight as well. The process of control schedule uses a mixed approach. This means it is just as important to ask how much have you done as it is to ask how much effort is left until you are finished. Performance reviews is a backwards-looking tool as well as used to determine any deviations from the plan. Applying this tool to the inputs, in particular the project schedule and the work performance information, helps to determine the following. When was the planned and actual start and finish date of a particular task? What is the variance and how big is it, and how much is there left to do? Having this type of information is what will help you as a project manager to determine whether you need to issue corrective actions or be proactive and issue a preventive action. We are not done with the performance reviews yet. There's more, because within this tool there are various techniques that can be used to actually measure, compare, and analyze. We'll take a look at 4 of these, beginning with trend analysis. Trend analysis analyzes project performance over time to find patterns, and these patterns, they will show whether the performance is improving or deteriorating. Used in control schedule, you can then detect trends in the work performance data and either take preventive action if there is a tendency towards a negative trend, or you take corrective action if the negative trend is present already to get the project progress back in line. Then we have the critical path method. This is a technique which we defined for you in the lesson on develop schedule. It's a method for calculating the amount of scheduling flexibility along your critical path. The critical path is made up of the sequence of activities that represents the longest path through the project and that cannot be delayed without delaying also your project finish date. Making comparisons of the project progress along the critical path can help you determine schedule status and also identify schedule risk, because if you have a delay on the critical path, your project is going to take longer. Our next performance review technique is the critical chain method, or CCM. PM. This is a schedule model that allows the project team to place buffers on any path of the project schedule to account for limited resources and uncertainties on the project. We talked about this in our lesson on Develop Schedule, and we also have a great interview for you in Module 80 about this technique with Alan Elder. You should really listen to that one. That brings this method alive for you. The goal of the critical chain method is to manage the project so that no matter what problems occur, you do not exceed your buffers. If you are successful, then the project will finish on time or even early. In the control schedule process, a comparison is made between the amount of buffer that is remaining to the amount of buffer that is needed to protect the delivery or the finish date. The difference between the buffer needed and the buffer remaining can then be the determining factor to whether corrective actions are needed. The slide title here, The Ultimate Technique, is really appropriate because according to the PMBOK guide, the absolute best, greatest, unsurpassed and most supreme tool that anyone can use to show variances and calculate performance measurements is, of course, earned value management. Earned value management techniques and earned value figures are used for performance reviews and variance analysis. In particular, we rely on the schedule variance, the SV, as well as the schedule performance index, the SPI. Both of these are part of earned value, and we cover them in detail in our earned value management lessons. What you should know about these measurements right here and right now is that they assess the amount of variation to the original schedule baseline. So they will tell you whether you are ahead of schedule or behind schedule. Of course, we cannot describe earned value management as the absolute best tool and technique to show variances without going into a little bit more detail about it. By employing earned value management, you have a number of great values available, like the schedule variance, the SV, or the schedule performance index, the SPI, that define exactly how your project is doing from a schedule point of view. But if you do not use earned value management, all that remains is percent complete, and this is just a numerical estimation of the amount of work on an activity that has been completed, and it's very difficult to estimate. So go ahead, ask anybody about their percent complete on an assigned task, and they may tell you, oh, I'm about 75% complete on this assignment. Ask them again the following week, and they may come back and say, well, still 75%, even though they have been working for a whole week on this task. Since then, it's very difficult to produce an accurate percentage. That is why in earned value management we often employ the approach that you only use 3 numbers. You say the percent complete is 0 when the task has not yet started. Percent complete is 50% when the task is in progress, and it's 100% complete when the task, the activity, has actually been completed and has been verified and validated. By taking this approach, you not only measure all tasks the same way, but it also removes the guesswork and it evens everything out. We already talked twice about the schedule variance and the schedule performance index, so how do you actually use them? Let's consider this example here where in task A we are supposed to create a user documentation, and we know that we are 2 weeks behind schedule for this task. You actually expected to be behind schedule at this time due to the illness of an employee. Also, this task is not on the critical critical path, so it will not delay the finish of the project. However, the customer has stated that they would accept a late delivery of the user documentation anyway. So no immediate action is required since this task is not on the critical path and does not affect the completion of your project. Well, the scheduled variance and scheduled performance index are just numbers. They are numbers that tell you where you are. As the project manager, you compare these numbers to the baseline and then you're able to determine if you are ahead or behind schedule. Because this task here is not on the critical path, the project will not be late, even though the customer has agreed to accept late delivery of your user documentation. So even if your schedule variance and schedule performance index here says, whoa, you're way behind, there is no need for action because you and your customer have already agreed on what to do on this particular task. For our next example, we have task B, which is the construction of a critical component. Here you are 2 days behind schedule of this critical component. The task happens to be on the critical path and several other tasks are dependent on it. If task B is not completed on time, well, your project is going to be late. You must take immediate action. In this example here, the numbers that you get for schedule variance and schedule performance index would indicate that you are behind schedule on this particular task. And as the project manager, you would need to decide the corrective action required to bring the schedule back into alignment. So, as you can see from these two examples here, while the schedule variance and the schedule performance index are just numbers that are given to you through a calculation, you as the project manager, you have to look at the individual tasks and say, well, yeah, on task A we're way behind. Our schedule variance and schedule performance index is really, really bad, but it's okay. But here on task B, even though we're only a fraction behind, we need to take immediate action. So the numbers of SV and SPI are just that, numbers. You have to apply them to your project and situation. As an alternative to earned value management, variance analysis is a technique used for assessing the magnitude and the degree of variation between the original schedule baseline and actual schedule performance. Deviations in the schedule are detected and you then decide whether to issue corrective or preventive actions. You also take a look at the total float and early finish variances to evaluate project schedule performance. And of course, nobody in their right mind would do any of this without the use of our next tool and technique, project management software. Well, we use software because most of the applications on the market today, they have the ability to show the planned start and finish days versus the actual start and finish dates. They can show you progress bars. You'll see a comparison to the baseline, and they have the ability to immediately display the effect of changes that you make to the schedule, like changes to the critical path or missed milestones that have just gone by and you didn't even notice. This is a very important tool, especially to a professional project scheduler. The resource optimization techniques are next. These are those methods that match scheduling activities with available resources to achieve goals. In this case, it involves taking both resource availability and project time into consideration for the scheduling of activities and the required resources for those activities. And of course, the scheduling tool is used to create an updated project schedule. This is accomplished by using supporting schedule data along with network analysis methods to generate an updated project schedule. And since we just talked about software on the previous slide, the scheduling tool in most software, that's just part of that. You press a button and it takes all your data and applies the scheduling tool to it and creates a schedule for you. We have reached the final 3 tools and techniques for the control schedule process, and all 3 deal with aligning project activities with the plan, but in different ways. Let's take a look at each one. First of all, we have modeling techniques. These are used to review different sequenced events or scenarios guided by risk monitoring to bring the schedule model back into alignment with your project management plan and the approved baseline. 2 examples of modeling techniques include the what-if scenario analysis and simulations. Then we have leads and lags. These are adjustments applied during network analysis to discover ways to bring project activities that are behind back into alignment with the plan. An example of adjusting, or in this case decreasing, the lag time would be when renovating a room. You adjust the start date for the hardwood floor installation to begin immediately after painting the walls, and you're not going to wait until the walls are dry. As soon as the painters leave the room, the people come in and start putting down the floor instead of waiting until tomorrow, so you can gain a day. And then we have schedule compression. This is a technique where you fast track or crash the schedule for the remaining work to bring the project activities that are delayed back into alignment with the plan. And most schedule compression techniques means adding more people, adding more resources to it. So we had 6 inputs, and to these inputs we applied 7 tools and techniques. Some of these 7 tools and techniques actually have sub-tool and techniques, multiples that you can use on the same ones. And of course this creates quite a number of outputs. They are the work performance information, schedule forecasts, change requests, and then 3 updates. Updates to the project management plan, updates to project documents, as well as updates to organizational process assets. Let's take a look at each. One of the tools and techniques we apply are the performance reviews. As a result of applying performance reviews to our inputs, the schedule performance indicators like the schedule variance and the schedule performance index, they are recalculated for all of our WBS components, particularly the work packages and control accounts. And then this work performance information, this updated SV and SPI, is documented and communicated to stakeholders, because what is it that stakeholders always want to know? How's your project doing? And from a schedule perspective, SV and SPI will give them that information. Schedule forecasts are estimates or predictions of future conditions and events for your project, and these are of course based on the available information that you have at the time that you make the forecast. As the project is executed, new work performance information, WPI, is provided, which is based on the project's past performance and expected future performance, and this then results in forecasts that are being updated and reissued. In other words, you look at what your project did in the past, you scratch your head and you say, based on what I'm seeing here, I predict, I forecast that we will be able to finish this project 2 days earlier than we had actually expected. Change requests are a common output of processes that are like control schedule in the monitoring and controlling process group. So it's not unexpected that it's also an output here. In this case, change requests address changes to the schedule baseline, scope baseline, and other areas of your project management plan. These changes, they can come about due to schedule variance analysis, progress report reviews, as well as results of performance measures. Remember, All change requests must be processed through the Perform Integrated Change Control process, and they include preventive and corrective actions. A simple example to illustrate is we currently have a monthly schedule review in place. However, we now find that we need to review the schedule more frequently, so we need to change the cycle to every 2 weeks. Therefore, we issue a change request via the Perform Integrated Change Control process to have it approved. We are moving on to our 3 outputs that are all about updating things, and the first one is the updates to the project management plan. This may require updating as a result of executing the control schedule process here, and 2 of them include, first of all, the schedule baseline, changes to the project scope, activity resources, or activity duration estimates. These will create changes to your schedule baseline, and in order to implement those changes, they must of course be addressed by an approved change request first. The schedule baseline may be updated to show changes as a result also of schedule compression. And then second, we may need to update the schedule management plan to show a change in the way that the project schedule is managed. A simple example we have just heard on the previous slide, where we talked about changing the frequency of our review meetings. Of course, in the end, that has to be documented in our schedule management plan. As a general rule, a baseline is updated whenever your customer requests a significant change. And by significant, we mean something like adding additional features to a product. That would be considered a significant change, which would require a change request and subsequent approval via the Perform Integrated Change Control process. Or if there is a new estimate for a particular task. For example, an increase of 75% in a specific activity's duration due to unforeseen technical issues. This will require approval and will update the schedule baseline. For more details on how and when to exactly update your schedule baselines, please take a look at our separate lesson about baselines. There are 2 types of documents that we think of when we look at the project document updates that are an output to this process. First of all, the schedule data. Approved schedule modifications and approved remaining durations are displayed in your new project schedule network diagram. And of course, then the project schedule itself. Schedule changes to the project lead to updated schedule data. This updated data is populated into the schedule model, which generates your updated project schedule. Our final output are the updates to the organizational process assets of our company. When we're performing the variance analysis, we need to know the answers to the following 3 questions. Why did a variance occur? What did we do about it? And what corrective action was chosen exactly? The answers that we get to these questions, they are then documented as part of our organization's lessons learned database. This is part of our organizational process assets. And of course, our input to this lessons learned database can then be used in future projects. They can refer back and see how we did things, how we dealt with variances. Let's review. From a time management perspective, control schedule is about controlling and managing the project schedule and any deviations from the schedule baseline that might occur. Control schedule is the only process in project time management that is not part of the planning process group. It is in the monitoring and controlling process group. All changes must be approved through the Perform Integrated Change Control process. And the best technique to show variances between the original baseline and the actual baseline is, what do you think? Yes, of course, it is earned value management. And it is, of course, earned value that gives us the two numbers of schedule variance, SV, and schedule performance index. These two numbers, they show you where you are in your schedule. Are you ahead or are you behind? However, as we have seen, schedule variance and SPI, they're just numbers. There is an art to understanding them, to interpreting them, and taking appropriate action based on the situation of that you are in on your project. Last but not least, we will also issue change requests which are needed for many kinds of corrective and preventive actions. And here is a sample exam question that you may find in a book or an online simulator. Which of the following tools and techniques uses fast tracking of the schedule to bring delayed schedule activities back into alignment? Is it A, leads and lags, B, the scheduling tool, C, modeling techniques, or D, schedule compression? Take a moment to think about this one. The correct answer is, of course, that it is D. Schedule compression uses fast tracking. Leads and lags and also modeling techniques, yes, they are alignment techniques, but they do not use fast tracking. And the scheduling tool is, of course, responsible for creating an updated version of the project schedule. It's the button you press in your scheduling software that delivers the new schedule to you. So schedule compression uses fast tracking. We have a second exam sample question for you, and it reads as follows. Which of the following is not an input to the control schedule process? Is it A, work performance data, B, project schedule, C, the activity list, or D, the project calendars? Think about this. Which one is not an input to the process? The correct answer is that it is C. The activity list is not an input to the control schedule process. Rather, it identifies the activities that will need duration estimates, and it's an input to the estimate activity durations process. However, I really hate this type of question, and here's why. Many of my students always ask me, do I have to memorize the inputs, the tools and techniques and outputs from every single process to answer questions like we have just seen on the previous slide? And these questions, they're actually quite dominant when you look around on the internet. My response is that you need to have a general understanding of what the inputs, tools and techniques and outputs are. It's much more important to understand the nature of each process. What is needed as an input? What do I need in order to execute this process? What tools and techniques will I be able to apply to these inputs, and what logically as a consequence then becomes an output? If you understand the concepts behind each process, you will be able to recall the ITTOs much more easily. And frankly, just learning a list of inputs, tools, techniques and outputs, how is that going to help you to become a better project manager? And this concludes our look at the control schedule process. So it's time for Justine to say,
just hop on the bus, Gus.
And I say, until next time.